Okay, this is the video that goes over exam 2. Exam 2 had 4 questions and it only covered node voltage. So you had to know how to write node voltage equations in order to make above 0 on this exam. So first of all, to remind you, node voltage equations are KCL equations, but they are always written in terms of node voltages. I think some of you did not watch a single video that I put up because it was all over the map. I had people drawing and labeling unknown currents everywhere. I had I1 through I8. I had current sources labeled with voltages instead of currents. I had people tell me that V1 was equal to 25 milliamps. So I just had all kinds of stuff all over the map. This was also a very, very simple test if you just bothered to watch the videos at all. Also, if you watched the videos, you saw problems that were almost identical worked out. You were not actually asked to find the answer on any of these, I don't think. No, you were not asked to find any answers. You were just asked to write the node voltage equations, which is exactly what we did in numerous examples in class, as well as solve them. So if you did the homework and you got them right and you didn't use the node voltage method, you should have been able to see that from watching the videos. Alright, so on this first one, this falls into the category of a circuit that has node voltages only. And so I've already labeled these and written the equations, so I want to provide the solution for you. The first node equation is written at node V1. I chose my ground at the bottom. We have 0.25 milliamps leaving, or we have 0.025 amps leaving the node, so that's the first term in equation 1. We have V1 over 330, that's the current through the 330 ohm resistor, and then we have V1 minus V2 over 150. The way this was graded is what I've written here are the necessary equations to solve. Actually, this one I think I did ask you to solve. So these are the two node equations. It was specified that you had to use the node voltage method. This was done because last semester I had a bunch of people who managed to go through the entire semester and never learned how to use the node voltage method. So that's why this test was specifically focused on node voltage. The second equation is the node equation written at node 2. And then finally, you have two equations, two unknowns. I did solve this. I don't list the values for V1 and V2 here. We were just looking for, could you write the equations and then could you get some answer? If you made a math error in V1 and V2, that was actually okay. We counted off at most 2 points if there was a math error there. Then the relationship between I sub 0, which you're actually asked to solve for, is V2 minus V1 over the value of the resistor, and I'm sorry, that should be, let me fix that. We graded it correctly, there should be a 0 right there. Sometimes this guy erases automatically. So you got 5 points if you knew that relationship. So 25-point problem. You got 10 points for each node equation. You got 5 points for being able to actually calculate I sub 0. You lost a point or two if you had math errors. So that was that. Okay, in this one, I labeled the node voltages for you. The first thing to realize and ask you basically, you needed to write a set of equations using the node voltage method that are sufficient to solve the circuit. I did not ask you to solve the circuit. In fact, I specifically told you not to solve the circuit and not to simplify your equations. And not to write any extra or unnecessary equations. Why did I say that? Because the point of the node voltage method is to create a minimum linearly independent set of equations. That's what it does. So if you go around writing a bunch of extra equations, that doesn't benefit anything, and the whole point of teaching the method is so that you understand that it minimizes the number of equations. Alright, so the first thing you needed is you needed the source equation that said that V2 is equal to 40 volts, and that was worth 4 points. And then the remaining node equations, one at V1, V3, and V4 respectively, were all that required the writing of node equations. So here they are, nothing different from what we did in numerous examples in class. The test was open book. I did have several hundreds, so good for you guys. You took advantage of all the materials and were able to do this just fine. I did say that it is okay if you did not have the first equation that said V2 equal 40, and if instead you wrote it directly into the three node equations. So in other words, everywhere you have a V2, if you substituted a 40 there, then we counted that okay, did not count off. If you had missing terms or sign errors in your terms, or one of the particular equations was incorrect, we looked at counting off about 1 to 2 points per term. So in other words, if you missed the 5 amps here, then we would count a couple of points off for that equation being incomplete. If you just missed the ballpark completely and didn't actually write node equations or didn't understand how to write node equations, I mean, I had people doing stuff like writing an equation for node 1 and putting V2 minus V4 over 40, which is completely irrelevant in node 1. So, if you did that or just totally didn't get how to write node equations, and there were some people who did not, then it's very possible you could make a 0 on this exam by just writing a bunch of random equations down, none of which were node equations. So that's this one. Question number 3. You were asked to, once again, the only difference in question 3 and question 2 is that question 3 contains a dependent source. And so that would require that you write this dependent source equation. First of all, you write the equation that defines the node voltage at V3. And then you have to write the equation that defines the variable I delta. So you need one of each of these, and then you need 2 node equations, one at V1 and one at V2. And so each equation here was worth 6.25 points. If you substituted V3 in directly, we counted that okay as well. Okay, finally, question 4 actually did not ask you to write a complete set of equations. It only asked you to do a couple things. It asked you, first of all, to identify, given the identified ground in this figure, and using the supernode method, where would the supernode be? And so I've indicated here in blue that encircles and incorporates node V1 and V4 in the same supernode. You needed to illustrate that on the figure, and that was worth 5 points. Then the supernode equation is shown here. So I've written that out for you. Getting that correct was worth 10 points. Then I asked you also to write the equations that define the dependent source variables in terms of node voltages. So the first one was V delta, which is basically the voltage between V2 and V3. It's V2 minus V3 because V delta is defined as positive on the V2 terminal. And then I phi is the current that goes through the 40 ohm resistor. So the voltage across that 40 ohm resistor in terms of the node voltages is V3. So I phi is V3 over 40. Okay, so that was it. Test should have taken you maybe 10-15 minutes to do at the outside. The only thing you actually had to solve for was up here in equation 1. You did have to solve these 2 equations for 2 unknowns. And even if you couldn't get a solution, most of the credit came from writing the equations and writing I sub 0. So as long as you had these relationships written down, if you didn't get an actual numerical value for the answer, you lost very few points on that. So that is exam 2. We are still in the process. I'm still in the process of completing the grading of exam 2. We've made a first pass, and now I need to go in and make a second pass. And if you are a person who did not upload to Blackboard, you currently do not have a grade because I have to find the email, and I have to check and make sure it was submitted within the 1.5 hour time frame and all of that. So given that this was an open book test, I did have several people make 100s, which is great. I had several people in the 80s and 90s, and then some other people who just, like I said, just completely missed the boat on node voltage. You will see node voltage again before the semester is done. All right. So that concludes going over exam 2, and I'll post both this video as well as the actual Word document.